Assalamualaikum and good morning. So we are going to continue with exercise 26.1 and we will be looking at question 8. If you notice, question 8 is a reaction between chromium with CO. It's called a complex. This is a chromium complex with PR3. PR3 is a type of ligands. Okay, so you will look at this ligand exchange reaction later on. But basically our reactants are the chromium complex and the PR3. Okay, so chromium complex is referring to this Cr with 6 carbon monoxide molecules. 2 separate experiments were carried out to study the rate of this reaction. In the first experiment, the ligand PR3 was in a large excess and the concentration of chromium complex was measured with time. The results are shown on the graph below. So the first graph, the curve in black, is the concentration time graph for your chromium complex. Okay, so this is an example where they combine the concentration graph of 2 reactants on the same axis. Okay, and then you are expected to plot in the second experiment. The chromium complex is now in a large excess and the concentration of PR3 is measured with time. The following results were obtained. So these are the concentrations of PR3 against time. So please plot this graph, plot these points quickly, and then they ask you to draw the best fit line. Now remember, it says best fit line. It does not necessarily have to be a straight line. Okay, best fit line can mean a straight line or a curve. Okay, in this case, you notice already my graph is the green graph for concentration of PR3. You might want to plot your own points and draw a straight line passing through all the points. Okay, so you might want to pause the video here. Moving on, so you can see that the points for PR3 is showing a straight line. And we are asked to determine the order of reaction with respect to chromium complex and with respect to PR3. In each case, explain how you arrived at your answer. Okay, so I'm going to use the graph that's given to me already. Okay, so starting with the black one. So this is a concentration time graph. If you look at your notes for a concentration time graph, your zero order would be a straight line. Okay, if it's a reactant, a straight line decreasing. This means that the gradient, the rate is the same at different concentration. Okay, it's the same gradient at whatever point you are in the reaction. And then for your first and second order and onwards, it is plotted as a curve. Okay, unless you find the half-life, then only you can confirm it's a first order or a second order. Okay, so what you're going to do to find the to find the order for the chromium complex, I think I've already given away the answer, the order for with respect to PR3, since it shows a straight line in the concentration time graph, then it is zero order. Okay, however, this is not the case for chromium complex. We cannot say that it is first order unless we confirm it. Okay, so the one way to confirm that this curve is showing a first order is to find the successive half-life. So we want to find at least 2 half-lives for chromium complex. Okay, so I am focusing on the graph of chromium complex. So initially, I start with finding T half 1, okay? Concentration, oh, sorry, I should label that later. So I start with concentration 0.01000, and the half-life is the time taken for the concentration to go down by half. So that means half of my initial rate would be 0.00500, and I need another one. Half of that would be 0.00250. Okay, so at initial concentration, my time is 0, and this is in second. Okay, so I will just leave it. And I want to find the time at my concentration 0.005. So I need to draw a line, and you will read it yourself. We should all reach at the same answer. Okay. Okay, so I won't tell you what it is, but I'm sure you can work it out yourself. Okay, you fill that in. What's the time at 0.005, and that first portion is your first T half. Okay, I call that T half 1. So I will label it here accordingly, T half number 1. If you want to say or confirm that the half-life is constant or increasing or decreasing, then you will need at least 2 half-lives. Okay, so the other time that you need to take is at 0.00250, which is somewhere here. Okay, so please draw it on your own graph. And that is, again, T half, but the second one. Okay, so what I want to point out is that your second half-life is only this section. Okay, you do not take the second half-life as 1400, 1400. Okay, you don't take the whole thing. So that's what students always make mistake. So your half-life for the second one is only just this part, right? And so if we were to add that in, okay, so that's another thing that you need to read off from your T half 2. Okay, so this working is actually not needed. If you can see the half-life graphically, then that's great. But the most important thing is you must show the line on the graph. You cannot just do an invisible line and say that the half-life is increasing or the half-life is the half-lives are increasing, decreasing, or constant. Okay, these lines are your working, so please make sure you draw them. These lines are your working, so it is important that you draw them. Okay, so you will say, okay, you will say that the order, do I have space there? Okay, I will answer it here. For number 2, the order with respect to chromium is blank because the half-life is blank. That's it. Okay, whether it's increasing, constant, or decreasing. Okay, which is, don't forget, which is whatever number in seconds. Okay. Don't forget, we also want to know the order with respect to PR3. Now, you do not need to find the half-life, because the fact that it is a straight line is already enough support or evidence to confirm that the order is 0. Okay, because the graph is a straight line. That's it. Done. Okay, so you can pause the video here if you need to work on reading off your graph to find the two successive half-life values. Okay, next, question 3. Write the rate equation for the reaction and calculate a value for the rate constant. Okay, so, right, rate equation is equals to K times, since PR3 is 0 order, we know that PR3 will not show in the equation. So only the chromium complex CrCO6 with whatever the number is after you have found the order. Okay, so they want you to calculate a value for the rate constant. So that means you need to find K using the method of initial rates. Okay, so since you are given concentration time graph, and remember that rate is equals to change in concentration over change in time. They already give you a hint that it's the initial rate. And if you notice, change in concentration over change in time is actually equals to the gradient. Now, we are only using the chromium complex graph or the chromium complex data because the PR3 is not shown in the rate equation. Okay, so we will leave the green graph alone. Okay, so how do I find my initial rate? That means it's the gradient at t equals to 0. Okay, so I'll just add that. Initial rate means gradient, cannot spell, at t equals to 0. Okay, so to find the gradient, you need to draw a tangent. I will use a blue line. Okay, a tangent that passes just to touch. That's not great. Just to touch. Okay, so it just touches the, of course, you know that I will ask you to extend your line, which is not that great, so that you can use a nice, okay lah, whatever, just imagine that that is a nice straight line. Okay, so my blue line is the line for gradient, which you know is the rate at t equals to 0. So you have to find the gradient, and that will give you the rate. Now, if you look at the expression, you can find the rate from the graph. You want to find K. What is your concentration of chromium? At initial, the concentration of chromium is 0.01. mole per dm cube. Okay, so this is 0.01. 0.01, yes, 0.00. Okay, and then you rearrange K is equals to rate over the concentration of chromium CO6 to the power of X, whatever. Okay, and then they want you to find the units, remembering that rate is mole per dm cube per second and concentration is mole per dm cube. Okay, so I will let you do that question, and to check your answer, you will submit your answer in the forms later, and then you will know whether you get the answer correct or not. Okay, so you can pause this video first while working out the answer for part 3 and 4. Okay, the next question, 4 possible mechanisms for this reaction are given below. Draw a circle around the letter next to the one mechanism which is consistent with the rate equation. So you can, even though I didn't tell you what the order is, you can already tell that the PR3 is not in your slow step. Okay, so because PR3 is not in the rate equation, so PR3 will not be in the slow step. So you just have to choose between A, B, C, and D, and the explanation would be so after you choose the answer, you will say because it is the only mechanism that does not involve PR3, PR3 in its slow rate determining step. Okay, and that's it. You will get 2 marks. Okay, 1 is for identifying which mechanism, and then the second part is for explaining that PR3 doesn't appear in the slow rate determining step. Okay, so if you want to complete this question, you can pause this video. Moving on to the next question, we will look at question 10. So question 10 is a reaction between, it doesn't say, bromoalkane at, okay, so bromoalkane with sodium hydroxide, right? So I'm guessing there's some more info, as this is only question B. Okay, but that's fine. We know that bromoalkane and sodium hydroxide would be the reactants for this reaction. The graph below shows the results of an experiment using the concentration of sodium hydroxide at 0.10 mole per dm cube. And this graph is the graph of the bromoalkane. Okay, so this is your bromoalkane. They use the symbol RBR. Okay. Now this graph is different from the one that we looked at earlier on, because in the in question 8 we were looking at a graph of the 2 reactants on the same axis. Okay, this time we are looking at the concentration of the bromoalkane at 2 different concentration of sodium hydroxide. Okay, so in a way, this is the graphical form of what you are usually given at in terms of a table. Okay, so this graph is when you use your sodium hydroxide at 0.10 mole per dm cube. So your sodium hydroxide stays constant throughout the experiment, and the concentration of bromoalkane changes. Okay, and then you are expected to plot another graph where sodium hydroxide is now at 0.15 mole per dm cube. Okay, so actually it is the concentration of sodium hydroxide that is changing. Okay, bromoalkane looks like it is the reactant. Okay, right. So let's just plot the graph first. Okay, let's plot the points first. Please pause your video and plot the points. Okay, so I have plotted mine, and that is, again, that's a curve, as you would expect, because if sodium hydroxide at 0.10 mole per dm cube is a curve, then if you change it, if you change the concentration of sodium hydroxide, then it should also be a curve. So that's 0.15 mole per dm cube. Okay, so sorry about what I said earlier on, that the concentration of the bromoalkane is changing. Actually, it's the concentration of sodium hydroxide. So this is the course of the reaction. All right, so this is the course of a reaction when sodium hydroxide is at 0.10 mole. And this is the course of the reaction when sodium hydroxide is at 0.15 mole per dm cube. Okay. Right. Plot this data on the axis above and draw a line of best fit. Okay, we've done that. Use one of the graphs to confirm that the reaction is first order with respect to RBR. Okay, so they want us to use the graph, and this is a concentration time graph. If we want to confirm the order of a reactant using a concentration time graph, looking at the shape is not enough. Okay, a curve can mean first order, second order, and so on, so forth. Okay, the only way we can say for sure that it's first order is again by looking at the half-life. Okay, so we are going to have space there. Maybe I'll just do it here. Okay. So if I want to know the order of RBR, I need to know the half-life. So that means concentration of RBR is starting from 0.010. Maybe I should not be moving my page up and down. Okay, so 0.010. Half of that concentration is 0.005, and half of that concentration again is 0.0025. Yeah, 0.025 is fine. And two successive half-lives is fine. Okay, you don't have to waste your time. If the numbers are a bit suspicious, then only you would do a further half-life, which is the third half-life. Okay, so you should start at 0.010, in which case your time is 0 minute. We're looking at minute here. Okay, so I will choose a different color. At 0.005, you will try to read that graph as best as you could. Okay, so that's your first half-life, and your second half-life would be this somewhere there. Okay, and we take this as your T half 1, and this as your T half 2. Okay, if you can see it from the graph, then that's great. If not, you will use this working. Okay, the time is then 0 minute to some number, and then at 0.025 you will read the number again, and this is our first half-life, and this is our second half-life. Okay, so please pause the video here and work out the value of the half-life, and then you will conclude. They want us to confirm, sorry. So you are to confirm that the reaction is first order. Okay, so if it's first order, then you should expect the half-life to be constant. So how would you write down the answer for that? Okay, so you would say the T half is whatever value that you find, and we will say that the half-lives or the successive half-lives are, actually I can just say the half-life is constant. Oops. The half-life is constant. And that's already, you should get, 1 mark. All right, you have to do a lot of things to get 1 mark. They must see the construction lines. Okay, these are considered as working. If you don't have these lines, then you will lose that 1 mark. It's the only mark for that question. Okay, next. Use the graphs to calculate the order of reaction with respect to NaOH. Show all your working and show clearly any construction lines you draw on the graphs. Okay, so remember, if you use the other graph, I can assure you, if you find the half-life or this other graph, you will also get first order, okay? Because this graph is of Bromo Alkane, okay? The only way you can work out for the order of sodium hydroxide is by using these 2 graphs, however, not its half-life. Okay, I repeat, this graph is representing the concentration of bromoalkanes, not the concentration of sodium hydroxide. Sodium hydroxide concentration is only, well, it's not plotted, but we know that initially this is how much sodium hydroxide you use, and this is how your concentration of bromoalkanes decreases as the reaction proceeds. Okay, so I repeat, you cannot use half-life to find the order for sodium hydroxide because the y-axis is showing the concentration of bromoalkane, not sodium hydroxide. So then how do we find the order of sodium hydroxide? We know we've got 2 concentrations here, 2 different concentrations. Okay, and here's the tricky bit. Remember, this is concentration over time. Concentration over time, you take the change in concentration over the change in time, you get the rate. But what rate? Not just any rate. This concentration is the initial concentration of sodium hydroxide. Therefore, you must use initial rate. Okay, so what is the initial rate when the concentration of sodium hydroxide is 0.10? And then what is the initial rate? Since this is initial concentration, you will then again find initial rate when the concentration of sodium hydroxide is 0.15 mole per dm cube. How do you find rate from this graph? The same way as you would like in the previous question, you will draw a tangent that passes through t equals to 0. Okay, so again, you may want to extend until you get a nice line, and you just take any number that looks like, don't know if you can see that in blue, that looks like a nice point for me. But then again, it depends on your own graph. Okay, so that blue line is the initial rate. You want to find the initial rate, which is the gradient, when concentration of sodium hydroxide is 0.10 mole per dm cube. Okay, that's your blue line. Next is your green line. I cannot use green, obviously. Maybe I can. So I will draw a tangent to the green line and I extend it. Okay, well, it's not great, but you'll do your best. So you can see that there's a nice point there. Again, it depends on your how you draw your line and how you draw your curve, of course. The green line is now how do I label this? Initial rate or gradient when concentration of sodium hydroxide is 0.15 mole per dm cube. Okay, it will take a while, especially it's your first time finding the initial rate of reaction graphically, but it shouldn't be impossible because I am pretty sure that all of you know how to find the gradient of a graph from a curve. Okay. Okay. So once you do that, I want you to tabulate them. It's easier to see. Use the graph. So that's part. I'll use a different color. Part 3. Okay. Show all your working and show clearly any construction lines. That means, yes, you have to leave the line there, and then you must also show the working of your gradient, remembering that gradient is equals to change in y over change in x, where y is concentration, x is time. Do not get that confused. I've also seen a lot of students carelessly do it the other way around, which is really not a chemical problem, but it's just really careless. After you got that, I want you to tabulate concentration of sodium hydroxide and the rate, initial rate. Okay, I believe that they have a certain, oh, they don't have the values of the, okay, the rate. They don't have the range, sorry, of the initial rate. So after you found the initial rate, I want you to tabulate them at 0.10 and at 0.15. Okay, Fill in the blank, what are the rates? So from here, you can then do the same method as we did in class. 0.15 divided by 0.10, that is an increase in 1.5. So you want to check with your rate, okay, after you found the two numbers, you want to check if they increase by 1.5 or if they don't, well, if they don't increase, they stay the same, or they increase by 3, in which case it's the square of 1.5. Okay, so from here, how the initial rate increases as your concentration of NaOH increases, it can tell you the order of the reaction. Okay, then only you can conclude that the order with respect to sodium hydroxide is blank. Reason, as concentration increases by 1.5, the rate, and then you just continue. Whether it increases, it stays the same, or whatever. Okay? Okay, so if you want to do that, please pause this video first and find the initial rate and then fill in the table. Okay, I will just show you, you don't necessarily have to prepare this table, but it helps to tabulate them so you can see. In the exam, if you don't want to draw this table, then that's fine, okay? Because they don't need to see this table. They just want you to explain. Okay, so please pause the video. Moving on to the last part of this question. Okay, so I can tell you that the rate equation, part 5, I'm just going to do it here. The rate equation is K times the bromo alkane, which is, I'll just call it X, and the hydroxide ion is Y, for example, okay? But I can tell you that both of them appears in the rate equation. They want you to calculate the value of the rate constant. So that means K is equals to rate over the concentration of RBr to the power of X and hydroxide ions to the power of Y. How do we fill in this information? Okay, so we have two experiments here. I'll call it the experiment A, which is the black line, and experiment B, which is the green line. Okay, so since experiment A is given to us already, I will stick with experiment A. At least we know that the graph is, we will get a more accurate value. Okay, there's nothing wrong with experiment B. It's just that if you think you don't trust your best fit line or best fit curve, then don't use B, use A. Okay, so we're going to use all the information from A. We need the rate, which is already found here. Okay, please do not repeat the calculation of the rate. We just use the initial rate value. So if you are using the initial rate, that means the concentration of bromo alkane is also at initial, which is 0.010 for your bromo alkane. And since we are looking at the graph A, our concentration of sodium hydroxide at initial is 0.10. Okay, so that means we know the rate, okay, which is initial rate. I will just put in bracket initial. RBR is our initial concentration at T equals to 0. It's 0.010. And then the concentration of sodium hydroxide, oh, I've written it down as hydroxide ions. It's the same. Sodium hydroxide, hydroxide ions, it doesn't matter, okay? But if you want to write it as sodium hydroxide, it's also not a problem, okay? If you think that in the exam you are more likely to write down sodium hydroxide, then change it to sodium hydroxide, okay? Or, okay, the concentration of sodium hydroxide in this case would be, since we're looking at graph A, it would be 0.10. So again, you can work out your rate constant since you know all this three information, and you can work out its units. And that should be done. All right. I will let you complete this question. Okay. So that is all for today. We will not do a lot of questions because I think you will need a lot of time to digest the information, especially for this graph, because I feel like this graph can be confusing because the y-axis is of bromo alkane, but then each graph is for different initial concentration of sodium hydroxide. Okay, so please take your time to really understand this question. If you want to try this question, question 9 is of the same format. Okay, you can try and check your understanding later on when I have provided you with the mark scheme. Okay. All right, so that is all for today. If you have any problem, please let me know. If there's anything that you don't understand, please let me know. It's extremely important that you understand and you know how to do these questions because they are real exam questions based on your past year papers. These are definitely in your syllabus. These aren't like old questions that you think, oh, maybe we won't get this kind of question. It is you could potentially get the same style or the same format of question. Okay, and before you go, there's also a form that you need to submit by 4:30 p.m. today, except for those who have their practical exam this afternoon. Okay, so only those people will be excluded. If you think you cannot complete the forms, please let me know, but make sure it is with good reason. Okay, do not just leave this exercise just because we're not having a physical class and then you just ignore. Okay, because to be frank, this topic is one of the easiest topics in your A2 syllabus, and I do want you to really excel in this topic. Okay, because once you understand, it's easy to score the marks if this topic comes out in the exam. Okay, all right then, assalamualaikum and thank you everyone.